Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
I, Philip Emeagwali, experimentally discovered how to email 64 binary thousand challenging initial boundary value problems of modern calculus and extreme scale computational physics, and how to email them to 64 binary thousand processors. I, Philip Emeagwali, experimentally discovered that those ensembles of processors define and outline a new internet that I visualized as my small copy or blueprint or prototype of the internet. I sent each of my primitive email to a 16-bit address or a unique string of 16 zeros and ones. Each email address had no @ or .com suffix. Each email contained 5 sets of data. I visualized each email as having 5 subject lines. I visualized each emailed processor code as a computation-intensive initial boundary value problem in modern calculus or extreme scale computational physics that I sent to each of my 2^16 processors. I visualized each emailed code as sent along 16 times 2^16 bi-directional edges of the cube in the 16th dimension that had a 1-to-1 correspondence with as many email wires that I visualized as short wires printed onto circuit boards or as long wires comprised of fiber optic cables. I visualized each email as sent with no message body. I visualized around a globe in the 16th dimension because my problems and their data or email messages were contained in 3 subject lines were received by 65,536 processors that I visualized as uniformly distributed around a globe in a 16-dimensional hyperspace. After each email was received, the 2 subject email lines that contained the sending and the receiving 16-bit long email addresses become useless. I discarded those 2 email addresses after each email was received. I visualized my new internet as outlined by 65,536 commodities that were identical to each other and that were equidistant from each other. Each processor was like a dim light in a sea of darkness. When supercomputing together as one seamless, cohesive supercomputer, those 65,536 processors became as bright as the sun. I communicated around my new internet that is a global network of 65,536 processors, and I did so by email, and I did so before each set of arithmetical computations, and I did so by imagining myself as 65,536 travelers in hyperspace. As an aside, any global network of commodity processors that are identical to each other and that are equal distances afar and apart from each other can be flattened from 3 or 16 dimensions onto a two-dimensional motherboard. Topologically, and to the supercomputer scientist or mathematician, that 16-dimensional network of commodity processors still remains a global network of processors. That global network is electronically soldered onto a two-dimensional surface. That global network on a two-dimensional motherboard is not renamed a two-dimensional network. To rename that 16-dimensional network as a two-dimensional network will be akin to renaming a 16-dimensional hypercube that was drawn on paper as a square, or akin to renaming a 16-dimensional hypersphere that was printed on paper as a circle. Put differently, I had one neural human brain enhanced by 65,536 electronic brains. My email travel paths were along communication email wires that encircled the surface of a globe in hyperspace that I visualized as short wires printed onto circuit boards or as long wires comprised of fiber optic cables. My destinations were my equidistant processors that I visualized as distributed on the surface of that hypersphere. I imagined myself, Philip Emeagwali, traveling into higher and higher dimensional universes. The farthest I could travel was to and from 2 to the power 64 equidistant processors. A new internet connected those processors and connected them with 64 times 2 to the power 64 identical email wires that I visualized as short wires printed onto circuit boards or as long wires comprised of fiber optic cables. In the 64th dimensional universe, I had an eureka moment. I discovered it will be presumptuous of our children's children to imagine they could construct a hyperbole that will talk in the 64th dimension to think 2 to the power 64 times faster. I was in the news headlines as a result of my experimental discovery of the massively parallel processing supercomputer. That experimental discovery occurred on the 4th of July of 1989. I was in the news headlines because I brought a new face, a new voice, and a new vision to the story of the development of the modern supercomputer. That is not a computer per se, but that is a new internet de facto. That experimental discovery of the massively parallel processing supercomputer that is the precursor to the modern supercomputer came from both intellect and intuition. For me, Philip Emeagwali, that precursor to the modern supercomputer, is the coming together of my 35-year life experience, life journey and experiences. Prior to my experimental discovery, the use of the massively parallel processing supercomputer and how to use the technology to solve the toughest problems in extreme scale computational physics was not taught in any university or tested in any laboratory. Nor can the technology be learned. Instead, the new massively parallel processing supercomputer that solves the toughest problems in abstract calculus and extreme scale computational physics and solves them faster than the vector processing supercomputer had to be seen for the first time, and seen on that 4th of July of 1989. By definition, to discover is to see something that was previously unseen. A scientist on a research for new knowledge is a truth seeker, especially new truths. A supercomputer scientist on a research for a faster supercomputer is seeking a new supercomputer, and especially a new computer. The discoverer becomes the first truth seeker. The scientific researcher is on his or her hero's quest for the previously unseen truth. Our never-ending quest for the fastest possible supercomputer has become our journey to the frontier of human knowledge. That never-ending quest has become a self-directed evolution in which we are both the creator and the created. That journey to the end of knowledge will force our post-human descendants of year million to address the larger question of who we are and where do we want to go. Daalụnụ, afam bụ Chukwura Philip Emeagwali, abụ m onye Ọnịcha. Bịa ga-afụ m na emeagwali.com. Ka o mesịa. I'm Philip Emeagwali at emeagwali.com. Thank you. Thank you. Thank you. Thank you.
Insightful and brilliant lecture. Insightful and brilliant lecture.